No sooner did the Webb telescope flash its impressive pictures across the world. You can do some search and even find the time to get blown by NASA, which is also planning the upcoming space telescope. In today's video, we're going to talk about SpaceX's insane new telescope. Stay tuned to find out. NASA has also confirmed that it has contracted SpaceX to launch its fresh Roman space telescope. The ship is in development, and it will go skywards between October 2026 and May 2027 from Launch Complex 39A at NASA's Kennedy Space Center in Florida atop a SpaceX Falcon Heavy rocket. SpaceX will also make $255 million from the contract. In some ways, the Roman Space Telescope is a successor to Hubble, with a basic mirror scaling around 2.4 meters, which is also the same size as Hubble's. However, Roman will have a large field of view, with its wide-angle lens prepared to see a region of the sky about 100 times bigger than what Hubble can see. It's expected to cost around $3.2 billion and $3.9 billion. Roman will begin a galactic exoplanet survey developed to find Earth-like exoplanets and also help astronomers realize how the universe expands. Its wide-angle lens will help it map the Milky Way and other galaxy 100 times sooner than Hubble and allow astronomers to notice the environments around galaxies in the early universe. It will be able to build Roman ultra-deep fields far more broader than the Hubble ultra-deep fields or even the first Webb deep field. It will also analyze dark matter and dark energy, new astronomy's greatest mysteries, and look for Earth-like exoplanets. In fact, Rome is also expected to find thousands of exoplanets, including more rogue planets than there are stars in the Milky Way, which is at least 100 billion. It will do that by using an amazing technique called gravitational microlensing. Microlensing is what Roman is all about. It's what makes it a different and special space telescope. It will enable astronomers to discover new kinds of exoplanets thousands of light years from Earth, orbiting stars near the center of the Milky Way. The technique is similar to how Albert Einstein's theory of common relativity was verified during a total solar eclipse in 1919. Its great sensitivity will allow it to observe when the gravity of stars and planets bend and magnify the light coming from stars that pass behind them from the telescope's point of view. Dr. Nancy Grace Roman, who is an American astronomer, spent 21 years at NASA. She then passed away in 2018. She is known as the mother of Hubble and remembered for making the theory of the space telescope into reality. In the mid-1960s, she headed up a council of astronomers and engineers to work on notions for a space telescope that assured both NASA and the US Congress that a strong space telescope should be a science preference. The Roman Space Telescope was previously known as the Wide Field Infrared Survey Telescope. NASA's James Webb Space Telescope has also caught the first detailed data for carbon dioxide in the atmosphere of a planet outside the solar system. These observations of a gas giant planet revolving around a sun-like star 700 light-years away gives critical insight into the compositions and shape of the planet. The finding, approved for publications in Nature, gives information that the future Webb may be able to recognize and measure carbon dioxide in the thinner atmospheres of minor rocky planets. WASP 39b is a hot gas giant with a mass around 1/4 that of Jupiter and a diameter 1.3 times bigger than Jupiter. Its drastic puffiness is connected in part to its great temperature. Unlike the cooler, more tiny gas giants in our solar system, WASP 39b orbits very close to its star, almost 1/8 the distance between the Sun and Mercury, completing one circuit in just over 4 Earth days. The planet's discovery was reported in 2011. It was made based on ground-based detections of the subtle periodic dimming of light from its host star as the planet transits or passes in front of the star. Previous remarks from other telescopes, including NASA's Hubble and Spitzer space telescopes, disclose the existence of water vapor, sodium, and potassium in the planet's atmosphere. Webb's unpaired infrared sensitivity has now announced the presence of carbon dioxide on this planet as well. Transiting planets like WASP 39b, whose orbits we identify edge on instead from above. It can give researchers with suitable chances to study planetary atmospheres. During a transit, some of the starlight is eclipsed by the planet totally and some is transmitted through the planet's atmosphere. Because various gases absorb unique combinations of colors, researchers can examine small differences in brightness of the transmitted light across a range of wavelengths to assume just what an atmosphere is made of. With its mixtures of inflated atmosphere and frequent transit, WASP 39b is a suitable target for transmission spectroscopy. The research team utilized Webb's near-infrared spectrograph for its observations of WASP 39b. In the emerging scope of the exoplanet's atmosphere, a small hill between 4.1 and 4.6 microns presents the first clear, factual evidence for carbon dioxide ever observed in a planet outside the solar system. No observatory has ever measured such subtle differences in brightness of so many unique colors across the 3 to 5.5 micron range in an exoplanet transmission spectrum before. Access to this part of the spectrum is important for measuring amounts of gases like water and methane, as well as carbon dioxide, which are believed to exist in many different types of exoplanets. Understanding the compositions of a planet's atmosphere is crucial because it tells us something about the inception of the planet and how it has evolved. The near-spec PRISM observations of WASP-39b is just one portion of a bigger investigations that involves observations of the planet using different Webb instruments, as well as observations of 2 other transiting planets. The investigations, which is part of the early release science program, was organized to give the exoplanet research community with strong Webb data as soon as possible. What are your thoughts on this topic? Let us know your thoughts in the comment section below. With that being said, it's time to end our today's video. Press the like button and subscribe to our channel for more interesting stuff. Peace out.